Hey everybody, welcome back. This is the third part in my series of how to design a box for the TS-100 soldering iron in Fusion 360. What you're looking at is where we left off. We have compartments for the power supply, for the irons themselves, for extra tips, extra tools, and some solder and maybe some soldering paste. So let's pick right up where we left off. We need to make a lid, and before I begin, let me show you. We're going to go to modify and change parameters, and you're going to see I added some parameters in. I added 3 parameters from where we left off last time. I added the lid height, which is going to be 8 millimeters, the lid width, which is going to be the box width plus the wall thickness times 2, and we added the lid depth, which is going to be box depth plus wall thickness times 2. So knowing that, we're going to say okay, and the first thing we have to do is we have to turn our body here, what you're looking at, we have to turn it into a component, and it's very easy to do. You're going to right click on where it says bodies, and you're going to say create components from bodies, and that converts our body here into a component, and you'll see we have component 1:1. If I click to expand it, it has its own origin and it has its own body, and it can have multiple of those things as well. And if you're wondering why it says component 1:1, if you had a design that had multiple identical components, you would see component 1:1, 1:2, 1:3, like that. So they all don't have to be separate. They can share bodies and origins. So, but we're only going to have 2 components, and they are not going to be the same thing, so we're not going to worry about that for now. So we need our lid. So we're going to come up and create a new component. So come right up to your assembly at the very top, right click on it, and left click new component. Now you'll see our other component, component 1, ghosts. That means component 2 is active. You can go back to make the other one active by putting your pointer on it over here to the left and click the radio button that says activate component, and now you'll be back here. And you'll notice our history is kind of gone. Our history is now going to be up in the assembly. But anyway, we're not worried about that either. We're going to go back to work on component 2. So let's create a sketch, and we're going to create it on that bottom plane, because as you know, when I'm designing something for a 3D printer, I like to think about it and design it like it's being built on a 3D printer. And that bottom plane is my print surface. That way it helps me keep straight in my head how things have to be printed to avoid failure or to avoid excess support, things like that. So we want to sketch a center diameter rectangle. So we're going to come here and say center diameter rectangle. And you'll notice as I move my pointer over, Fusion is kind enough to expand the grid out for me. So I'm going to put my pointer over here till it kind of locks into that center, and I'm going to come out here. And all I really want to do is I could make this thing 3 feet out into space if I wanted, but I just want it out far enough so that the two aren't intersecting. So I'm going to click, and I know I want my lid width to be lid width, and there it is. That's what I put in earlier. I'm going to hit tab, and I know I want my lid depth to be lid depth. And there we go, and hit enter to lock them in, and now you'll see the Fusion actually puts the numbers in, not just the name of the parameter. So, and you'll see the FX in front of it means that this number is coming as a function of a parameter or something else, an equation, anything. It means I didn't type them in, it's coming from somewhere else. So we want to hit E to extrude, and we're going to click on that, and we're going to extrude up lid height, and there it is right there, and enter or OK to lock it in. And here's kind of an interesting part coming up, and this is a part that I tend to goof up right off the bat, and because I tend to goof it up, I like to double check it before I print something that's wrong. And if I did that a little bit more often, I'd waste less filament, but we're going to do it here. So I could make this a number of different ways. I could use multiple rectangles, and I could make a smaller rectangle in here, and then I could use push-pull, and I could cut it down. But you know what? I love the shell command, so that's what I'm going to use. I'm going to say modify and shell. I want to shell this, and this is where it gets interesting, because this is where the math and the geometry kind of gets more than my head can contain on a Sunday. So I'm going to shell this all thickness. Now, I want this lid to be when I made the can cooler holder, if you saw that video, I made the inside of my holder the same size as the outside of the can cooler. And I did that because I wanted it to be a press fit. I didn't want the cooler to fall out if I turned the whole thing upside down by the handle. And I also don't think I'm ever going to be taking it out, or it's my plan to never take it out. But let's say wall thickness, and wall thickness, and what we're going to do here is we're going to go into inspect and measure, and I want to measure my, doesn't matter which one of these lines I use, and that one there, and 200. My box is 200, so this is going to be a press fit, and I don't want that. And I'm thinking I want like 1/4 of a millimeter all the way around so that the lid will go on and it will still be kind of snug because this is a 3D printer, not machined stainless steel. So the lid will still go on, but you know how 3D, how plastic is. It'll go on, it'll probably still be fairly tight, but I won't have to wrestle it. So let's go close to that, and let's get this back on here like that, like we want to look at it. And let's come down to our shell command and say edit feature. So I want to go wall thickness minus 0.5. And that's going to move it in. I hope that's going to give me a 1/4 millimeter gap all the way around. But let's measure it. Measure, and we're going to measure from there to there, and now I have 201 millimeters, so that wasn't right. That gives me a 1/2 millimeter gap all the way around, which I don't want. So I need to have, see, this is where measuring comes in, and why for some reason it's hard for me to wrap my head around some of this geometry sometimes. So we're going to right click on our shell command, we're going to say edit feature, and we're going to change our 0.5 to 0.25, and let's see if that gets me what I want. And okay, and let's measure again. Inspect and measure, or I, and we're going to measure from that line to that line, and now we have 200.5 millimeters. So that, I think, is what I want. That's going to give me a 1/4 millimeter gap all the way around. I'm happy with that. So close, and this keeps me from wasting more filament after I make a lid that's either too tight or too loose, or doing a lot of sanding. I hate sanding PLA. It drives me bonkers. I never get what I want when I sand PLA. So unless I'm just trying to smooth it a little bit, and as long as I don't get the plastic too hot, then it's okay. So now what we want to do, we could basically be done right here. And I could just export both of these components as STLs, but let's make a joint because we're only at 8 minutes. So let's make a joint. Joints are fun. So I am going to say assemble and a joint. And this is where things get kind of tricky. I know I want the center of this, so I'm going to click it. And I know I want a slider over here, and it has sliders set for me. A lot of times it pops up as rigid, but I know I want a slider. If it comes up rigid, change it to slider. And I know I want to flip the part over. So now that's component 1 selected. It's asking component 2 to select where we want on component 2. And this is probably where it's not going to be right. I would like to have the inside of this, but there's no way I'm going to get it. Since I know that's a 3 millimeter wall, this should be pretty easy to figure out. My extra little gap is probably going to hose me up a little bit, but let's zoom out. Let's see if it will let me get that right there, and then you should see Fusion flip the lid and assemble it. Goofed up. Okay, we're going to cancel that, and let's try it again. I didn't have to cancel it. I could have just changed the location, but assemble a joint. And we know we want there, and I want to zoom in a little bit better because I obviously had that not placed correctly, and we're going to say there. And okay, now it flipped the lid and it put it on right, but as you see, our motion isn't correct, and we're not correct this way because I couldn't get the center of that top surface. So I'm going to move it over, and how much to move it over? Probably wants to be wall thickness. Wall thickness, let's see what wall thickness gives us. Well, wall thickness moved it the wrong way, so it wants to be minus wall thickness, doesn't it? Minus wall thickness, there we go. And that wasn't enough. I think I need wall thick minus wall thick. How about minus wall thick plus 1? Oh, Oh, that was the wrong way, wasn't it? Minus wall thick, -1. How about that? And that didn't take into account for my gap. So how about minus wall thickness minus 1.5? And that's not quite there either, but it's darn close. I don't know. That's pretty darn good. As AVE says, good enough for the girls I go out with. I'm going to say, okay, I could go get the measuring tool and I could mess with the measuring tool, but you know what? Good enough for me for what we're doing here today. We're not even really using this joint for anything. It's just for fun. So if we look down here, we say slider, and we say we want to slide on the z-axis, which is of course up and down. And we're going to animate. First, I'm going to say okay to that measurement. And now let's come back into our joint. Our joint disappeared, didn't it? No, it didn't. There it is. How come it didn't show up down below? Anyway, we're going to come to our joint, and here's slider 1. And I'm going to right click it, and I'm going to say animate joint, and there it is. But we don't want it going through our box, do we? So I'm going to come up the joint again, and you see this little button out to the right of joint, right in here? This says edit joint limits. I'm going to click on that. And now you'll see over here I have a box that says edit joint limits. Our motion is going to be slide, and we're going to set a minimum and a maximum. And the minimum, I'm thinking 0 is probably okay for the minimum. The maximum, let's make 50 millimeters, just because we want to see it go up high enough, but we don't need to see it go off. Now where it says rest, if I wanted this to rest at any place other than minimum, say I wanted it to rest halfway through, I could type in 25 millimeters for rest and we'd be good to go. Let's say animate, and I think that's what I want, so let's say okay. Let's come up to our, check on the radio button next to our main storage box, our assembly, so that we can see the whole thing. And now let's say slider animate. Pretty cool, huh? So there we have our box, and there we have our joint and a little animation to show it. And let's export our component. So let's go to component 1. We're going to right click on it. We're going to say save as STL and click OK. And let's call this TS-100 box bottom and say save. And let's go to component 2 and left click save as STL. And we're going to call this, oh, we got to say OK. And we're going to call this TS, and I'm just going to click this one. And I didn't need to call it box bottom, did I? I only needed to call it bottom. We're going to call this lid and say save. And now we're going to minimize this, and we should have these here. And here's the TS-100 lid. Let's open it up in Cura and let's see if it prints the way we want it to print. I want to make sure that I'm printing in the correct orientation. Since I designed it face down, it should, and there it is. And let's do the same thing for the other one. Let's open it and take a look at it. And there it is. So I'm going to print this. I'm going to print this in PLA on the Ender 3. And next video, I'm going to come back and show it to you. We'll see how it works and see if I'm happy with it or if I need to make adjustments. My only real concern is the smaller compartments may be hard to get things in and out of. But, you know, I can always flip it upside down, I guess, into the lid. So that's it for today. If I've helped you, if you've enjoyed this video, if I've at least entertained you and made you laugh and feel better about yourself, please like and subscribe. If you have any questions, leave them below. I've got some affiliate links to GearBest and Amazon below as well. If you would use them when you need something from either of those two, it would help me out, or at least every now and again, it would help me out and it doesn't cost you any more. Have a great day, and I will see you next time. Bye for now.